In this video session, we're going to see about the registers which are used in the microprocessors. The three main important units, or we can say the digital units in a microprocessor, is registers, ALU, and the control unit. The registers are nothing but the same registers which most of us have studied in digital electronics, logic design, or digital design course. Now, arithmetic and logic unit. In digital design or digital electronics, you are studying about adders, subtractors, and some of the logical units. The same is used inside the microprocessor. Control unit such as decoders, multiplexers, encoders, all these are used to control the data operations, control the flow of data from registers to this ALUs. ALU, which is also called as arithmetic and logic unit, is the main neuron of this microprocessor. You know that inside human brain, these neurons are something which is actually processing the data. In the same way, in microprocessor, these are the units. These are the digital units which are processing the data. Now in this video, let us see about registers. What are registers? You all have studied D flip-flop in your digital electronics or digital design. If you put these digital units, if you put these D flip-flops in series or in cascade, depending on the number of bits, you get shift registers. Shift register is something you all have studied in your digital electronics or digital design. This also works like a storage device. You can store a 16 bits if you have cascaded 16 D flip-flops. So 16 bits are stored and also shifted to the right or left using these shift registers. So this register is an important part of your microprocessor, because in microprocessor what happens is the data processing. The data which is going to be processed in arithmetic and logic units is first stored in these registers, and from these registers data will go to the arithmetic and logic unit, and then the result will be stored back to the registers. So having this type of registers is the basic requirement of your microprocessor. You all know that 16-bit is 2 byte, right? 8-bit is 1 byte. So this is 2 byte register. Hope all of you understood what is register. Registers are nothing but a storage element where not only storage, you can also do the shifting operations. Now let us see how many registers are there in your 8086 microprocessor. Your microprocessor era starts from 8080, 8085 and so on. Now let us see specific to 8086 microprocessor. You have multiple 16-bit registers inside the microprocessor unit. You have AX register, BX register, CX register and DX register. So you have multiple registers. When you have multiple registers, to identify these 16-bit registers, it has to be named. Right? Whenever you want to name any object, we name it as A, B, C, D like that. In a similar way, in 8086 microprocessor, these registers are named AX, BX, CX and DX. AX, BX, CX and DX. These are 4 registers along with other registers, and these registers are called as general purpose registers. General purpose registers. Once again, I am reminding you, what I am explaining you in this video is the internal parts of the microprocessor. You not only have AX, BX, CX register, there are other registers called SP, BP, SI and DI. SP is called stack pointer, BP is called base pointer, SI is called source index, DI is called destination index. The functionality of these registers will be known when we take a specific topic on this microprocessor. So here you see these are the register set of microprocessor, that is 8086 microprocessor, right? So if somebody asks you how many registers are there in 8086 microprocessor, so you have several registers, several 16-bit register. That means each register can save 16-bit of data, right? See, AX, BX, CX and DX registers are called general purpose register. That means it is used for any purposes. That means you can put data, you can store data, 16-bit data in this, which can be a operand, which can be an operator of the data to be processed. These data are stored in this general purpose register. But the other registers which you see here, which is called a stack pointer, base pointer, source index, destination index, these registers are used for special purpose, for keeping the pointers of a memory. You know, these microprocessors are used along with the memory. So when you use the data from the memory to get the data from the memory, to fetch the data from the memory, or to data to be stored in the memory, you need an address in the memory. That address is nothing but a pointer, and that pointer can be stored in this SP, BP, SI and DI. So memory pointers also can be stored in the 16-bit register, and also you can see your data, nothing but operands, also can be stored in this. So this storage element is the part of your microprocessor. Let the microprocessor be any modern processor, the present day processor, it has this. It need not be 16-bit. As the technology evolves, it can be 32-bit or it can be 64-bit. We are living in the era of 64-bit microprocessor now. So, understanding this basic registers is very important to understand all the higher versions of these registers. So, these registers these general purpose registers can also be used as a two 8-bit register. So for example, my data is 8-bit. When my data is only 8-bit, then why I should go for 16-bit? In such cases, these general purpose registers can also be used as two 8-bit registers. For example, this AX register, you can use upper 8 D flip-flops, right? At upper 8 D flip-flops as another AH register, right? And lower 8 flip-flops, this as a lower 8-bit registers. So you can put two different 8-bit datas into AH and AL separately. Similarly, BHBL and CHCL and DHDL. See, so using this 16-bit register as a two separate 8-bit register is possible only with this general purpose register. You cannot use SP, BP and SI and DI register as a two separate general purpose register. You have to use it as a full extent 16-bit. So I have told you this SP, BP, DI, SI and DI are used to keep the offset addresses. This offset address is nothing but a pointer address to the memory. When you access a memory, right? See, microprocessor need data, right? We cannot keep all the data in this registers. These registers are inside microprocessor, right? Now, data has to come from memory. Memory, you have the data. To access memory, to fetch data from the memory, you need an offset address. That offset address means it's a pointer to a particular memory location, right? So these SP, BP, SI, DI are used for that, right? So this is about the registers. Hope all of you understood about the registers. This is a part of your microprocessor. So knowing what is this register is very important to understand the microprocessor basics. Thank you for watching this video. Let us see more videos like this on microprocessors. Thank you.